the micrometer. The most important measuring tool in machine shop work is the micrometer caliper, used to measure variations in size too small for the human eye to see. Different types of micrometers are used to measure inside widths or diameters, outside lengths or thicknesses, and the depth of holes or cuts, but the principle used by each is the same. The micrometer caliper used in measuring thickness or outside length has a sturdy frame on which is mounted a hardened steel anvil. This frame supports the barrel, which has a scale graduated in 25 1/1000ths of an inch. Inside this barrel is an internal screw. Engaging the barrel screw is one end of a hardened steel spindle. The thimble is part of the spindle assembly and contains a scale graduated to represent 1/1000th of an inch for each division. The micrometer uses the principle of the screw to control the movement of the spindle. The screw has 40 threads to the inch. 40 turns of the spindle move it 1 inch. Therefore, one complete turn of the spindle moves it exactly 1/40th of an inch. 1/40th of an inch is 0.025, 25 thousandths. The barrel is marked off in divisions, each of which represents a 25 thousandths movement of the spindle. Remember, one turn of the spindle moves it 25 thousandths of an inch. If we take the full distance around the thread and make a straight line of it and divide that line into 25 equal parts or divisions, we will have a simple illustration of the scale which encircles the thimble. It is apparent that each division represents 1/25th of the travel of the screw as it makes one complete turn. Since one complete turn makes the spindle travel 25 thousandths of an inch, it is evident that each division represents 1/25th of 25 thousandths, or 1/1000th of an inch. Each division on the thimble represents a spindle travel of 1/1000th. The scale on the barrel is graduated in 25 thousandths of an inch. Each turn of the thimble moves the spindle the distance of one graduation. Each fourth graduation is numbered. 4 times 25 thousandths equals 100 thousandths. The zeros are dropped in order to make the scale easier to read. The complete scale on this micrometer shows that it has a range of 10 times 100 thousandths, or 1,000 thousandths, or 1 inch. Micrometers come in standard sizes designated by the largest opening of the micrometer and in steps of 1 inch. Most sizes, however, measure only 1 inch in thousandths. The 1-inch micrometer measures from 0 to 1 inch in thousandths. The 2-inch from 1 to 2 in thousandths, and the 3-inch from 2 to 3 in thousandths, and so on. The most commonly used micrometer is the 1-inch. Here the thimble is being turned to bring the spindle into contact with the work. The measurement is read by first reading the number fully visible on the barrel. This is 6. Remember that each of these figures should be read in hundreds. Therefore, it is 600 1/1000ths. Beyond the 6 mark, there is visible another graduation. This gives us 25 thousandths. On the thimble scale is shown the graduation that is stopped on the index line, the 1/1000th graduation. The full reading is 0.626, 626 thousandths. The ability to take accurate measurements with a micrometer depends on skill in its use. There is a feel to a micrometer that tells the skilled workman when he is using the right pressure in turning the thimble. Precise measurement can result only through proper use of the micrometer, and constant practice is the only way to acquire the necessary skill, to acquire the right feel. Until the operator is skilled in the use of the micrometer, he may measure the same piece at the same point and get different readings. Constant practice will develop the skill necessary to obtain uniform readings. Gentle pressure of the thumb and index finger on the thimble is sufficient to bring the spindle into contact with the work. As the spindle reaches the work, the drag of the fingers over the knurled surface of the thimble tells the operator when he uses the right pressure. The micrometer is a sensitive instrument for precision measurement and must be used with care. The good operator does not use it like a C-clamp, or swing it around when changing the setting, or lay it where it can drop to the floor, or where it can pick up abrasive particles or dirt. These things affect the accuracy of the instrument. Before using the micrometer, the careful operator removes all burrs and nicks from the work. The good operator makes sure that anvil and spindle are free of dirt or chips. The diameter of the shaft which has been measured is determined by referring first to the scale on the barrel. The figure 7 indicates .700. Two more graduations are seen. That's another .050, which is 50 thousandths. On the thimble scale, the number 1 graduation registers opposite the barrel index. That's .001. The diameter of the shaft is .751. Several places are gauged with a micrometer to check the diameter through the entire length of the shaft. The standard micrometer in experienced hands will give accurate measurements to 1/2 of 1/1000th or finer. Micrometers are often used in measuring 2 or more thicknesses of material. Since the combined thickness here is more than 1 inch, a 2-inch micrometer is employed. The figure that appears on the barrel scale is 7 or 700 thousandths. Then 2 full graduations of .025 each, that's 50 thousandths. The 0 on the thimble scale is exactly on the index line on the barrel. Remember, a 2-inch micrometer is being used, so 1 inch must be added. The total is 1.750. All micrometer calipers should be checked frequently, making sure that the 0 line on the thimble lines up with the barrel index. Those larger than 1 inch should be checked with special standards or gauge blocks. A 2-inch micrometer is checked with a 1-inch standard. When the micrometer is closed down over the standard with just the right tension and feel, it should register 0. A 3-inch micrometer is checked with a 2-inch standard. Larger instruments are checked with correspondingly larger standards. A companion tool to the outside micrometer is the inside micrometer. On the inside micrometer, the jaws or points expand to fit the part to be measured. The micrometer is held square with the inside surfaces of the work and the measurement taken across the center of the hole. Another type of inside micrometer uses rods to measure the diameter of large holes. Rods of various lengths are inserted in the instrument according to the size of the hole to be measured. Accurate measurements of very large bores can be taken with this convenient tool. Other convenient tools for measuring internal diameters in medium-sized holes are telescoping gauges, which are shaped like the letter T. One arm is movable. A screw locks it in place. It's often used for checking the diameter of cylinder bores and other deep holes. The setting of the telescoping gauge is measured by an outside micrometer. Another type of micrometer is used for the accurate measurement of the depth of holes, slots, and other depressions below surface locations. The depth micrometer has a slender rod that reaches easily into small holes and slots. Rods of various lengths adapt the instrument to measuring holes of various depths. Micrometers and micrometer measuring tools are used in every machine shop. If the micrometer principle is understood, these instruments are easy to read. If the right type of micrometer is selected, accurate measurements can be taken for outside measurements and for inside measurements and for depth measurements as well. If they are kept clean and used properly, on work clean and free from burrs, they will give the precise measurements that make modern mass production possible. All micrometers are precision tools, and the good operator takes pride in his ability to use them properly. He knows that the thimble should not turn too freely or too tightly, and that the anvil and spindle must be kept separated to prevent corrosion, and that they must be kept in adjustment to assure accurate readings. The good operator gives them this care, oiling them to prevent rust and corrosion and keeping them in a protected place.